Linear motion. Linear motion is motion in a straight line. Displacement is the distance covered by an object moving in a particular direction measured from the initial position. Speed is the rate of change of distance per unit time. If a car covers 100 kilometers in 2 hours, its speed is total distance over total time taken, which is 50 kilometers per hour. Other units of measuring speed is meters per second. Velocity. When the distance moved by an object is in a specified direction, the speed is called velocity. Velocity is displacement over time, that is, distance in a particular direction over time taken. Note that velocity has both magnitude and direction. Such quantities are called vector quantities. Example is displacement. Speed has only magnitude and no direction. Such quantities are called scalar quantities. An example is distance as well. Acceleration. When the velocity of an object changes with time, the object is said to have an acceleration. Acceleration is the rate of change of velocity. Acceleration is given by final velocity minus initial velocity over time taken. If a vehicle starts from rest and reaches a velocity of 4 meters per second in 10 seconds, acceleration will be 40 minus 0 over 10, which is 40 meters per second. Distance time graph. If the distance covered by a moving object is recorded at certain time intervals, the values obtained can be used to plot a distance time graph. Consider the values shown below. The following graph can be obtained from the values. The gradient of the curve is equal to 4 over 2, giving us 2 kilometers per minute. The gradient of such a graph gives the velocity of the object. That is, gradient is equal to velocity, which is equal to change in distance over change in time. When the object is accelerating, a nonlinear curve is obtained. Consider the figure below. To obtain the speed at certain time, that is instantaneous speed, we draw a tangent at that point and find the gradient of the tangent. Velocity time graph. When the velocity of a moving object is recorded at time intervals, a velocity time graph is obtained. Consider an object that accelerates from rest to 50 meters per second in 4 seconds, retains this velocity for 3 seconds before decelerating to rest in 2 seconds. The graph will appear as follows. The gradient of the graph in the initial phase gives the acceleration. At constant velocity, acceleration is 0. When velocity reduces with time, it's negative acceleration, also called deceleration. acceleration or deceleration is equal to gradient and is equal to change in velocity over time taken. Interestingly, the area under the graph gives the total distance covered by the object for the whole time period. Relative speed. When a vehicle is overtaking another, it appears to be traveling at a slow speed. However, when two vehicles are traveling towards each other, they appear to be traveling faster. This is called relative speed. Generally, when two objects are traveling in different directions, that is, towards each other, their relative speed is the sum of individual speed. If traveling in the same direction, the relative speed is the difference in their individual speeds. This is illustrated below. Let's take an example. A car leaves point P and travels at 50 kilometers per hour towards point Q. At the same time, another car leaves town Q and travels towards P at 100 kilometers per hour. If the distance PQ is 600 kilometers, A. How far apart are the cars after 1 hour? B. After how long will they meet? C. How far from P will they meet? We can sketch the journey as shown below. Relative speed is equal to the sum of their speed since they are traveling in opposite directions. That is 100 plus 50, which is 150 kilometers per hour. After 1 hour, the distance traveled will be speed times time, which is 150 times 1 hour, which is 150 kilometers. They will have covered a total of 150 kilometers in 1 hour. The remaining distance will be 600 minus 150, which is 450 kilometers. B. The relative speed we've seen is 150. Total distance is 600. The time taken is given by distance over speed, which is 600 kilometers over 150 kilometers per hour, which gives us 4 hours. The vehicles will meet after 4 hours. C. How far from P will they meet? Total time for the journey is 4 hours. Let's find how far the car from P will be after 4 hours. Speed of P is 50 kilometers per hour. The time it takes is 4 hours, and the distance it will have covered will be 50 times 4, which is 200 kilometers. The cars will meet at 200 kilometers from point P.
I think one of the problems with math is if you aren't strong in it, you end up with weak spots in the foundation. And so if you want to build on that, if you want to go in and major in it or to do honors in it, you really do need a solid foundation. And so if you don't have it, if you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university.